Hello, my name is Andrea Anton, and I'm coming from Saudi Arabia, where I'm doing my postdoc. And first, I want to thank you for staying here for the last talk of the conference. And I'm going to talk. I'm going to talk about latitudinal gradients on seagrass meadows in the Red Sea. So the Red Sea is a warm sea that is characterized by several gradients. I'm going to focus here on two of them. The first one is the temperature gradient that increases towards the south. And this graph here was created in the last 35 years, and they did the average of the maximum temperature. And they reported that it goes from around 27 Celsius to 33 for the maximum temperatures. But where we find the seagrasses, which are in very shallow areas, you find them in warmer environments than this 33. And here is a gradient that it decreases towards the north, that is for nutrients, and here is represented as the concentration of chlorophyll. So we were interested in seeing how these natural gradients are affecting seagrasses, and particularly their metabolic rates. So there aren't any studies on seagrasses in like most of the studies are here done in the north of the Red Sea, but we look at studies that they look at their primary producers and the effects of these latitudinal gradients. And then there's this paper by Sewell and collaborators that they work with this Posilopora verrucosa, a very common species in the Red Sea, and then they wanted to see what the effects of they look at a latitudinal gradient, and also they broke their measurements in two seasons. September it would be the warm season, and March is the cold season. And they found that for gross primary production, there wasn't an effect on season, but there was a significant effect on latitude. And the primary production of this coral was increasing towards the south, and they found a little bit of thermal inhibition on in the very last location. And then for seagrasses, coming back to seagrasses, this was a recent publication done in the Gulf of Aqaba here, and they found that in contrast there's a strong increase in net primary production for seagrasses when the temperatures increase, and they found that increase in the summer, and it's probably because this was done with Halophila stipulacea, that it moved closer to the thermal optima during the summer. And also we did in our group, we measure a maximum electron transport rate for also Halophila stipulacea, and here I present as a proxy for primary production. And although we found a trend of an increase towards lower latitudes, this trend wasn't significant. Also, we look at several factors that could influence productivity. So we measure nitrogen and also iron concentration. The Red Sea is very oligotrophic, and it has been shown that nitrogen can limit production. And also we look at iron limitation in this. Most of the sites, they have carbonate systems to see if iron actually could be related to productivity on the meadows. So the specific questions are, what were the metabolic rates of seagrass meadows along a latitudinal gradient in the Red Sea, and if these metabolic rates are seasonal, and also try to find factors that they may be explaining any limitations for productivity. We got in two cruises, one in the winter in January 2017, the other one in the summer in July 2017, and these are the sampling sites. During the summer, we survey in Duba and all the way to Al-Lith, and the local temperature in the seagrass meadows was from 23 to 27.4. And then during the summer, we were able to add this also location in the southern part of Saudi Arabia, and the temperatures were from around 30 in the very north to 32 in the Thalassian banks. And we surveyed in 10 seagrass meadows in total, and we found 5 species, which were Thalassodendron cilliatum, Thalassia hemprichii, Halodule uninervis, Halophila stipulacea, and Halophila ovalis. We were arriving to the locations, but we didn't know in which places they were seagrasses or not. So I don't have, for each latitude, I don't have data for all the species. But whenever we found a meadow, then I collected 3 to 4 cores per species that was found on that meadow, and then I brought those cores to the boat, and I ran incubations in a flow-through tank that maintained the local temperature, and also the water that was in the cores had the same nutrients that were found on the site. And I measure metabolic rates through following oxygen evolution, and I use a FIVOX4 presence oxygen sensor. And also, once the incubations were done for several hours in the dark and in the light, then we measure nitrogen concentration and iron concentration in the blades of the seagrasses. And these are the results. There's quite a lot of information here, so I'm going to break it down. First, here I have put them up so you can see all the sites that we were surveying, and then the information for each latitude is here. These are the 5 species of seagrasses, and here is the rate. In this case, is gross primary production. And then here I have a table with the results for the statistical results. And I ran one model for each species, and I had 2 predictors. One was categorical, that was season, summer or winter, and the other one was continuous, which was latitude. And we found, unlike reported for corals, there was a strong effect of season. So all the seagrasses, they increased their production in the warmer months. And only for one species we found a latitudinal gradient increasing towards the south. That was for Halodule uninervis, which in fact it has been shown that it has a high tolerance to high temperatures. And for Halophila stipulacea, we found that there was an increase during the summer in the very north latitude, but that was a decrease in the middle latitudes, which is here in Thugal. There was it's not significant, but there was it was a different trend, the only one that saw a different trend, which this correlates with the previous presentation that they may be in the native range, which is the same species, Halophila stipulacea, the one that is embedded in the Mediterranean. So, and also we didn't find it in the other, the most southern latitudes, so it could be quite sensitive. And then also I saw here this, these lines represent the average gross primary production for these 3 species. And I just want to point out that the gross primary production in the Red Sea for these species, and I will have to look for more information on these ones, are below the gross primary production mean that is reported elsewhere for these species. And for respiration, we found similar results. I'm not going to show them here, but similar results that for primary production, although the rates were slightly lower. So then when we do the ratio between gross primary production and respiration, the ratios were actually quite high for all the species. And again, I have shown here the mean reported for those species, and for these 2 species, at least they were above those ratios. And then coming into what may explain these low primary production rates, the first one that we looked at was at the nitrogen concentration in the leaves, and there's no indication that there's a change on the nitrogen concentration on the leaves related to latitude or temperature. And also, if you look at the mean values that have been reported for these 3 species, Halophila stipulacea, hemprichii, and uninervis, they are above that average that has been reported. But I'm going to show here is very preliminary results for the iron concentration in the tissue of the seagrasses, but I wanted to show you because for all the measurements that we did in this species, iron concentration seems to be limited, and in fact for some of the species it's below 100 milligrams per kilogram of dry weight, which has been shown to be critical. So it seems like the limiting factor in these meadows, it seems from the preliminary, is going to be iron. So as a conclusion, a strong seasonality on gross primary production that increased during the summer because the meadows, they approach, they get closer to the thermal optima. A latitudinal pattern only for 1 species. And the seagrass meadows, they had generally high ratios of gross primary production versus respiration, so quite autotrophic, and also generally low metabolic rates as compared with the same species global means. And it doesn't seem to be that they are nitrogen limited, but iron limited. Thank you.
Questions?
How much summer-to-winter temperature difference variance we have done?
How much temperature?
Water temperature between summer and winter.
Okay.
Down the coast.
Okay. So for the winter, we found that it was from 27 to 29 from the north to the south. I have the numbers in one of them in the very beginning here. So from
And was there less variation in that?
so that was measured in the meadow, yeah, with a CTD when we were collecting the. So that's in the meadow, yeah. Was that your question?
I just meant between the sites. Was there a difference in the magnitude of difference between summer and winter? So say compare this
Yes.
summer away from the winter.
Mm-hmm.
Each of these sites, there are big changes in their.
Yes, so I don't have those numbers, but it would be, for instance, this would be for Duba. In the winter was 23, and in the summer was almost 30. And it will be so far with the other sites. I don't know if the difference, it was exactly the same, but yes, there were differences in in all of them, in all the latitudes, yes.
No, just one question. You were pointing out that iron could be one of the drivers of this lower primary production, particularly in the south, no?
Mm-hmm.
But in the lower latitudes. But actually, at the beginning, well, a couple of things. One is that you showed that the chlorophyll was actually higher in the south, and phosphorus limitation actually tends to be also very strong on chlorophyll.
Mm-hmm.
And how that may explain this contradictory result. And also you are finding a high production, no? Towards the south.
Yeah.
So you think that the iron limitation is actually through all the Red Sea, or it's...
I think we recently published a paper where we did measure in different 18 species of seagrasses and macroalgae, and we found that they are generally, like, I think it was 90% of the species, they had some deficiency in iron. And I don't remember, I think there were 8 of them that their values were below this critical level of 100. So I think it's at the basin level, and I think it's several factors. There's probably iron coming from the south, but there's also iron input from dust. So it's probably more homogeneous than having a gradient that it decreases towards the north. Is that, yeah?
The oceanographic system is quite different in the local upshot because you have very deep sea in the winter.
Mm-hmm.
So it might be interesting to compare the study to a similar coast study in the Gulf of Aqaba on the Saudi Arabian side. The oceanography is mixing when you have a higher concentration of nutrients and iron.
Mm-hmm.
It's a smaller geographic range, but from the oceanography, the conditions between summer and winter are very different.
Okay. And do you know the concentrations of like iron? I think is quite high. No. Okay.
Yeah. Just a quick one, this is more related to the previous one about salinity temperature.
Mm-hmm.
I know that having sailed with Red Sea years ago, the salinity does change quite a bit between
Yes.
the bottom and top.
Mm-hmm.
Would that be consistent with any change, any synergy, would say? Say it's about 34, 35 at the bottom, it can get up to 40s near the Gulf of Aqaba and Suez.
Yes.
So would
Yes.
be exact any considerations there in the interpretation?
Yeah, so there could be a confounding factor because you get these gradients. Salinity increases towards the north and temperature decreases towards the south. We measure salinity in all the sites, and we will include salinity on a little bit more sophisticated models for analyzing the results. Yeah. But
Consider the previous.
yes, but the salinity is having, yeah, absolutely.